Hey, it's David with Oklahoma Ham Radio. I just want to give a short project update on where I'm at. So stick around. If you don't mind, please hit those like, subscribe, and bell buttons so that you know when new videos are posted. Made some progress. Check it out. So first off, please excuse the mess of a desk that I have here. I'm waiting for a new desk to be delivered, but you know, in the world we live in, it takes a long time to get things. So here's the controller box. I'm going to redo this plate right here, do it in two different colors. I tried to paint it and then wipe it off, and didn't really work real well for me, but there is a power button on the back. Hopefully this is coming across okay. I don't have this hooked up to an antenna at all, but you can see this is working. The encoder is working, showing the steps that it's trying to take. I'm going to turn it off real quick and then turn it back on so I can show you the other features. So the menu button does work. Potentiometer works. The switch works. Just going to exit that. Anyway, all the buttons, all the switches, all that good stuff all work as intended. So I just don't have it hooked up yet to a stepper motor or anything. I'll show you what I've got going on there. Go ahead and turn this off. I did add an on-off button in the back, obviously. So here's the stepper motor with the 10-to-1 Planet gear gearbox. Going to a coupler, going to a little bearing, going to a slide that's going over here to the end, which ultimately this will be connected to that variable capacitor. So I've got some glue going on here to hold this part in place before I glue it, and I don't have this guy screwed in yet. Okay, as this rotates, this slide slides, and this end piece rotates, the coupler to the variable capacitor. So what this will do is slide down and attach or hit limit switch is one on each end, hopefully. They'll be right down here at the bottom, right down here. And when it hits that end, it should try to stop, or it should stop rotating the motor, which is being simulated by me here. It should stop rotating that motor and let the controller know, hey, you've hit the end of your limit as to what you're able to go. So what I'm able to get is about 12 rotations, full rotations out of this motor, which should take me 80 down to 40 roughly. And I'm just I put a little bit of lubricant inside of here. It's a nut sauce that came with that I bought when I was building a guitar. And this all seems to be working fairly well. So let me get this rotated back where it needs, well, somewhere where it needs to be. I need to screw in this bearing. And when I printed this bracket that all this is sitting on, I printed it in 3 sections. So I printed this section, and then this end section. This is actually a 4th piece that goes on. That allows you to adjust up or down just a little bit. But there's these little clips like this that I've got that clip in these side pieces. This clip isn't printed yet because what I'm going to do is come off over here with the connection where this would go, this would plug in, and then the limit switch would plug in. Those will go back over maybe Cat 5 or Cat 6 cables, something like that, to this DB9 connector, which will, communicate back to the box. So the problem that I have is I have a flex radio. So this is a EZB V4 controller. The cool thing about it is it is Wi-Fi. It can connect via Wi-Fi, and this is a serial port that can communicate to another serial device. So what I should be able to do is take this device, wire it into this device to handle that transmission of the serial data, and then remote control the motor from the communication. So how in the world do I do that? Well, this EZB V4 controller, you can program the software to control this. So where does this software run? All this device does is acts as an extension of your computer, really. So you're communicating from the computer to this device over Wi-Fi, and then you can send data or control motors or whatever with this device. So what my plan is that the SDR software can communicate to the software driving the EZB controller to send that communication whenever frequency changes happen. And that EZB controller can then set with the radio device, the stepper motor controller, which ultimately drives the variable capacitor on the magnetic loop antenna, to pass that information over. So there's API calls that I can call. I can get data back out of the radio through the software that can run on your iPhone, on your iPad, computer, whatever. And you get that data back out and pass it over the Wi-Fi signal to the EZB V4 controller, which passes it to the controller box, which passes, controls those motors. So that's my thought as to what I'm going to work on and try to get going. The cool thing is that EZB V4, Easy Robot software, can't remember the term of it or what they call it right now. It's changed. But anyway, that software would allow me to run on an iOS device or a Android or PC or whatever to communicate to that V4 controller. So after I get this box and this stepper motor variable capacitor controller, whatever you want to call it, finished up, and get it towards tuning the antenna. So now that variable capacitor is laying horizontally in that antenna configuration. I may mount it vertically, which could change, probably will change, the location or the where the variable capacitor has to be set in order to get the lowest SWR and highest signal, so on and so forth, on the different frequencies. So those are the things I'm working on right now. It's a bigger project than I thought initially, but they always are, right? 73. Have a great day. Stay safe. Bye.